Take 17. Oh my gosh, this one's taken me a while. Plus, my dog's all antsy right here, so she's kind of helping. So, for this molar mass, molecular weight, all sorts of different ways to say these words, it's basically just the mass of 1 mole of whatever substance it is you're talking about. Okay? This becomes a very fast thing. You have to be able to do these quickly because they typically are not the end of the problem. They're just some little thing you have to do during the problem. So we have the situation here, we're going to do 5 of these relatively quickly once I explain it. You do it to 4 significant figures, so you don't have to think beyond that. Just don't worry about it. Do the calculation. At the end, make it 4. Okay? So for all of these, we're going to do these one at a time. Basically, all you do, you take how many of your first element times the mass of your first element. Use these figures. Don't just say 12. Say 12.01. It's there for a reason, okay? So we have 6 times carbon. We have 8 hydrogens. Hydrogen is 1.008. And we have 6 oxygens, 16.00. Okay. Equals 176.1. Now, it could be AMUs. It could be grams per mole. There's all sorts of units you're going to see here. They're all the same. All right? It could be Daltons. That's a biochem thing, but still, it happens, okay? That's the first one. Moving right along. Now we're going to do this one. So we have 3 carbons. So we have 3 times 12.01. We have 5 hydrogens, 1.008. So we have 3 nitrogens. So that one you might have to look up if you haven't done it yet. And then 9 oxygens, 9 times 16.00. So again, you do that, do it in your calculator, 4 significant digits, 227.1. I'm going to use grams per mole because to me that's a better unit. That's the best unit to use. Okay, number 3. Now calcium. We have 3 calciums, so 3 calciums, which is 40.08. Now, our next element is phosphorus, but how many do we have? We have 1 in phosphate, but we have 2 phosphates, so it's better just to say that we have 2 of them. And they weigh 30.97 each. Okay. And now, same for oxygen. We have 8 of them. Not 6, not 4. Okay. So, 4 sig figs. I'm hoping this is why I do so many takes on this. I'm hoping that I don't, because they're all right on top of each other, and I make sure I just get these right. Okay, platinum. We have 1 platinum in the periodic table, 195.1. That's not a very common one for me. Chlorine is 35.45. Nitrogen, we have 2. That was 14.01. And we have 6 hydrogens. Again, 4 significant digits. So 300.1 grams per mole. Last one. We have 3 coppers. Okay. Copper is what? 63.55? Now we're going to have all sorts of things. We're just going to go in order. I'm not going to try to combine everything. I'm just going to do it 1 element at a time. So we have 2 oxygens. Those are 16. We have 2 hydrogens. Those are 1.008. I'm going to have to go on the next line just so you know. We have 2 carbons. Those are 12.01. And then don't forget, we have 6 more oxygen. It's 16.00. We could have combined them and had 8 oxygens total, but to me, bookkeeping sometimes gets real tedious, especially with some of these really huge things. And so I feel just be methodical, go through it, and you should get 344.7 grams per mole. Whoa, all sorts of things are happening. That is that problem.